All right, so we're looking at FSA Review Number 4. All right, so let's look at the quick review. So it says, sometimes there are constraints to when an equation works for a real-world situation. When this happens, we have to be able to determine what the appropriate domain is for the function. All right, so the equation C of S is equal to 10S is given for the cost of a total number of shirts. So the first question is, can we calculate the cost of a negative number of shirts? So let's think about this. Are you going to walk up to someone and be like, hey, I have -5 shirts in my closet? No, you may say, I got rid of 5 shirts, so that means all you're doing is removing 5 shirts, but you're not calculating the cost of 5 shirts. So can we calculate the cost of a negative number of shirts? No. Can we calculate the cost of 0 shirts? Well, yes, 0 shirts is $0 in this scenario. So yes. Can we calculate the cost of a positive number of shirts? Yes. So therefore, we can say that the equation represents the situation only when x is, so you can say it's greater than or equal to 0. Because you can calculate 0 number of shirts costs $0. And then when you start working your way up, 1 shirt costs $10, 2 shirts $20, and so on. So now let's look at the next scenario. So sometimes a solution to a problem does not make sense and can be eliminated. So the height of a baseball after being hit by a batter is given by h of t is equal to -16t squared plus 60t plus 4, where h of t is the height and t is the time after hitting the ball. You are asked to find the time it takes the ball to hit the ground. After substituting 0 for the height and solving using the quadratic formula, you determine that the time is approximately -0.07 seconds and 3.82 seconds. So for number 5, so do both of those answers make sense? I'm immediately saying no, because I've never heard of calculating negative time, and the y would be in the real, like, you cannot have negative time. All right, so then what is the final solution to the problem? So it would be the 3.82 seconds.